Hello everybody, and welcome to another video on my channel. Today will be the first video of our forces or dynamics part of our mechanics series, which is a sub-series in this channel, which is all about explaining and clarifying physics topics for all of you. So I hope you enjoyed this video, and without further ado, let's get right into it. In our past couple of videos, we studied how objects move. We figured out how to predict where an object would be if we knew how much time it had traveled for, or the velocity, or the acceleration, etc. But we never figured out why all of those things happened. Why is this object moving, and what makes this object move? Forces clarify all of this and are the answer to this question. And now, since we can study forces, we are fully prepared to start uncovering more about the secrets of motion and how it works. Of course, though, this is not the only thing that will be covered. Forces are still only just a small part of explaining the full story behind motion. We still have to understand what powers these forces, which is energy, and also if they rotate, or let's say they have a collision, so then we will need to understand momentum and impulse. And also, now that we understand what we're going to cover today and how this fits into the grand scheme of things, let's start by covering the most basic type of forces, which are the forces that we control, or the forces that we apply on things. Let's start out with a definition of a force. A force, normally in common terms, is a push or pull which changes an object's acceleration. With this definition written down, let's go into dissecting it. A push or pull is basically, we push or pull something, or we're trying to change the motion, which is where the second part, which I would say is the most important part, comes into play. And that's the fact that it changes an object's acceleration. And acceleration is changing velocity, etc., etc. But what's important is that it changes an object's acceleration. Now, this acceleration and this change in an object's acceleration can also be written as a Newton's second law, or F is equal to ma. Basically, force is equal to mass times acceleration, and this changes the acceleration into one fact that I didn't put that's also very important that I decided to save is net. Now, the net acceleration is the sum of all the accelerations, or all the forces divided by the mass on the object going on at one time. So let's say we have an object over here, and it has a force going downward, F1, a force going here, F2, and a force going here, F3. Now, its acceleration would be direction dependent, and what this would do is we would be able to figure out the net acceleration also if we knew the mass. What would change its net acceleration then would be another force, let's say this, F4. And since this F4 force counteracts this F3 force, it would be less of going in the left direction. So if we had the right direction as positive x, we would be going more towards a positive acceleration in the x dimension. If this all sounded confusing, don't worry, it will be cleared up as we explain more of this video. So now that we know about changing an object's net acceleration, we can figure out why it changes the acceleration, which will be a topic for a video in the future, as we haven't finished changing all our topics about forces. The next thing that we need to know about forces is that they are directional, or that they are vectors. And I said vectors are something with a magnitude and direction. So vectors, magnitude, and let's say we have a vector, a magnitude, and direction theta. This was covered in a previous video, so if you want to know more about that and you want to learn more about that, please go check out that video, as it's a really good video, I hope, and it explains a lot of the review that's also going to be needed for topics going forward. So now that we have our explanation of vectors, etc., etc., and the fact that forces are directional, we can go into the next part, which is explaining what all the different types of force are. There are many different really ways a force can be applied and many different forces you'll need to know about when solving problems. The few most common ones are as follows. We have friction, gravity, Hooke's force or like Kx, which is a spring which is related to springs. We have just an applied force that's already applied. We have tension, and there are many more, but these are just the most common forces that will be used in a lot of these problems. Now, oftentimes these forces have specific formulas related to them, like the coefficient of friction. Friction is the coefficient of friction multiplied by the normal force, which is another type of common force which is perpendicular to the surface. And speaking of surface, let's talk about how these surfaces really work. So normally, at the very beginning, you will encounter problems like this. We have a surface over here, we have an object, we have a force, let's say 80 newtons over here, and we have the mass of this object as 5 kilograms. And we have gravity being applied, and the coefficient of friction is 0.4. Now you might be like, what? How does this work? How is this a simple problem? So let me break it down to you. So first, let's figure out what this problem is asking for. In this case, I'm going to be asking for net force. So we have F net, or our net force, over here. After that, we're going to figure out what the F net is. The formula for net force is the net force is equal to the sum of all the forces. Now, if I didn't cover this, we can also have a sum as this, which is a capital sigma. So sum of all the forces in the equation, or that is being applied on the object. So what we need to do is first, we need to identify we have an applied force, which is one of our types, which is oftentimes going to be given, and that's 80 newtons. And then we have over here friction force, because I have a coefficient of friction. So involving calculating frictional force is we have the frictional force is micro times the normal force. So 0.4 times the normal force is equal to the force by friction, like this. And then we have our applied force. So F applied is equal to, now we have around equal to 80 newtons, or actually exactly equal to 80 newtons. And we have our mass of 5 kilograms. So let's get into talking about the normal force, as clearly that's our biggest unknown over here. The normal force is perpendicular to the surface, and make sure that there is no really any net change in the vertical direction unless it's shown to be so. So since there is no change in the vertical direction, don't assume really any change when these types of problems are talking about. That means the normal force is equal to the gravitational force. Since the gravitational force is not pulling the object within the surface, we have our normal force, which is the force that resists that force because of Newton's third law, which will also be covered in another video. So we have over here 5 kilograms times gravitational acceleration. So 5 times 10, which is mg, which is gravitational force, that's equal to 50 newtons is the normal force. And since we have our coefficient of friction over here, 0.4 multiplied by 50 newtons is equal to 20 newtons of the frictional force. Now, since the frictional force always opposes motion, which is another thing that is often covered in many courses, you will have the net force, since 80 newtons is in the direction of the motion, you will have 80 newtons minus 20 newtons is equal to 60 newtons. And there we go, our first example solved. This is a quick taste of what you will really encounter in many problems, in many examples, and I hope this got you introduced to the concepts of forces as vectors and the fact that there's many different types. Now, the biggest thing also that should be known is the fact about direction, as I said, and one more extremely important tip would be to draw something called a net force diagram, or just a force diagram. Now, a force diagram has an object as a dot. Let me show you an example quick. We have an object as a dot over here. Then we draw all of the forces in their respective directions. So let's say we have a force F1, which is at a 30-degree angle to the horizontal. So we have F1 over here. Then we have F2, which is straight downwards. We have F3, which is like upwards and a little bit to the left. And the angle over here is 10 degrees to the horizontal. But then we also have a normal force opposing this force. So we have F of N over here, F of N over here, and then this is F of gravity. Let's say this is F2. So this is a diagram, a dot diagram, and it just quickly shows all the forces. As oftentimes in dynamics, you will be figuring out net force and net acceleration through the lens of Newton's laws, which will be covered in our next video, as this video is only to get you introduced to the concept of dynamics and what it holds for you. So thank you so much for watching this video. If you found this video educational, helpful, or any other way just a really good video, please make sure to like, subscribe, and hit that notification button for more awesome videos just like this, and be sure not to miss anyone and watch some of my other videos. In addition to that, please make sure to comment down below anything where if you want my channel to improve on, or if you notice any quality improvements in general, any questions, or just anything that helps boost my channel and helps me make it better for all of you. So thank you so much, see you in the next one, and bye bye.